Look around your kitchen, your bathroom, your car. Even in the skyscrapers that scrape the clouds, you'll see it everywhere. Shining, strong, and almost immortal. Stainless steel. It doesn't rust, barely stains, and keeps its silvery glow year after year. But here's the strange part. For thousands of years, humans battled rust. From swords that withered to bridges that crumbled, we could forge iron and steel, but we couldn't protect them from nature. Then, just over a century ago, we cracked the code by accident. Today, stainless steel is in surgical tools, jet engines, and even the International Space Station. Yet few people know the story of how it was born, out of war, chemistry, and one man's curiosity with a gun barrel that refused to rust. Let's uncover how stainless steel is really made, from the fiery heart of the furnace to the smooth cutlery at our tables, and how an old problem led to one of the modern world's most invisible revolutions. Before we can talk about stainless steel, we need to talk about rust, the enemy that never sleeps. When iron meets oxygen and water, a chemical reaction begins, oxidation. Iron atoms react with oxygen to form iron oxide, that reddish-brown flaky substance we call rust. The problem? Rust eats away at metal, weakening it from the surface inward. Ancient blacksmiths could make strong swords, but even the finest blades would eventually corrode. Civilizations from the Romans to the Victorians tried every trick, oiling, painting, coating, but rust always returned. By the 1800s, when the Industrial Revolution demanded stronger machines and new ships, the world needed a metal that simply didn't rust. That's when scientists began experimenting with chemistry, asking how can we make steel that resists oxidation itself?
Our story turns to early 20th century Britain and a metallurgist named Harry Brearley. Born into poverty in Sheffield, England, a city famous for its steel, Brearley worked his way up through the foundries, obsessed with improving metal for the weapons industry. In 1912, while studying new steels for gun barrels, he noticed something odd. One of his experimental alloys, containing a bit of chromium, refused to rust, even after weeks exposed to acid and air. Most steels turned reddish-brown, but this one stayed bright. He realized chromium formed a thin, invisible layer of oxide on the surface, a self-healing barrier that stopped further corrosion. Without knowing it, Brearley had discovered stainless steel. At first, factories weren't impressed until local cutlery makers in Sheffield saw it. Knives that didn't rust or dull? That was revolutionary. Within a few years, rustless steel, later renamed stainless steel, began to spread worldwide.
So what actually makes it stainless? At its core, stainless steel is mostly iron, about 10 to 30% chromium, and often small amounts of nickel, carbon, and molybdenum. When exposed to oxygen, the chromium reacts to form a microscopically thin film of chromium oxide, only a few atoms thick, that shields the metal beneath. If this layer is scratched, it reforms almost instantly in air or water. That's what makes it self-healing. No paint, no coating, just chemistry. Different compositions make different grades of stainless steel. Austenitic steel, like 304 or 316, is the most common type, non-magnetic and found in kitchenware and architecture. Ferritic and martensitic steels are stronger and harder, used in tools, turbines, and knives. This tuned chemistry means engineers can create steels tailored for almost any job, from acid-resistant tanks to decorative surfaces that gleam for decades. Now let's step inside a modern steel plant. The making of stainless steel begins with raw materials, mainly iron ore, chromium, nickel, and carbon-bearing substances like coke. Melting. These materials are fed into an electric arc furnace where lightning-like arcs reach over 1600 degrees Celsius. The metals melt together into a molten bath. Refining. Oxygen lances and fluxes are used to control carbon and sulfur levels, achieving the desired chemical balance. Casting. This molten steel is poured into molds, forming long slabs, rods, or billets. Hot rolling and forming. These glowing pieces are repeatedly rolled and pressed to achieve thickness and strength. Annealing and pickling. The steel is heated again to relieve stress, then cleaned in acid baths to remove impurities and oxide scale. Finishing. Finally, it's polished, textured, or cold-rolled to give it that familiar mirror or matte finish. By the time it leaves the factory, it's ready to become everything from a jet engine blade to a kitchen spoon. What's remarkable about stainless steel is how quietly it shapes our world. It's in medical tools and implants, food processing equipment, building facades, and high-speed trains. Architects use it for its strength and beauty. Think of the Chrysler Building's shining crown or the Cloud Gate sculpture in Chicago. Because it resists corrosion, it lasts decades longer than normal steel, saving energy, reducing waste, and staying recyclable forever. In fact, around 90% of stainless steel is recycled at the end of its life. It's a near-perfect material loop.
The story of stainless steel isn't finished. Researchers today are creating new super stainless alloys that resist extreme heat, salt water, and chemical attack. Some are used inside nuclear reactors and desalination plants. Others are being tested for hydrogen storage, a fuel of the future. And in an age of sustainability, stainless steel's durability makes it a quiet environmental hero. It's tough, fully recyclable, and endlessly reusable. The same piece of steel could one day be part of a bridge, then a car, then a coffee maker. Harry Brierley once said he wanted to make a better gun barrel. Instead, he gave us a material that built our modern world. From a humble lab bench in Sheffield to the towering skylines of our cities, stainless steel has become a silent symbol of progress. It doesn't shout for attention, it simply lasts. The next time you see that silvery shine on your sink, your watch, or an airplane's engine, remember, it's not just metal. It's more than a century of human ingenuity, chemistry, and resilience, forged in fire and polished by time. If you enjoyed exploring the surprising history of stainless steel, give this video a like. Share it with someone who loves learning how everyday things are made. And subscribe for more stories from simple things, surprising histories. Because sometimes the most ordinary objects hide the most extraordinary stories.